The first thing you were asked to do was to work on the first three problems, or 3, 4, and 5 there, okay? And to graph them and then decide what kind of function they are. So if you were looking at the first problem there, -2, -2, comma 1, -1, comma 0, when you graph it, I think it looks like that. Okay. What kind of function is that? Yes.
Quadratic.
What's that?
Quadratic.
Quadratic. How can you tell?
I don't know how to. I can use process of elimination.
Process of elimination. Yeah.
Because they're like scattered.
Because they're scattered. Yeah.
That's what.
Yeah. Here's the key to this. At least so far, we only have 3 different kinds of functions that we've talked about. And the 3 different kinds of functions graph like this. One of them is a straight line. So that would be a linear function, right? One of them is exponential, and that's one that for a long time stays sort of horizontal and then suddenly swoops up like that. Okay? Let's do them in different colors so that they don't look like they're part of the same drawing, right? Okay. And then the other is quadratic. And that is a parabola that either points up like this or points down like this, but either way, it's something that completely changes direction and goes the other way. If on one side it's going up, on the other side it's going down. It's got some point in the middle where it changes direction. Okay. That's the only one of the 3 that does that. So when you're looking at this, I mean, I think you're absolutely right. The process of elimination will work here. This is clearly not going to be linear because even if we could draw a line that sort of went like that, suddenly we're missing these 2 points. And even if you thought, well, maybe this is exponential because it's coming down and it's curving and it might go like that, that last point tells you this thing is going to change directions completely and head back up. At this point, with only 3 different kinds of functions on the table, right? We only have 3 different kinds to choose from. The quadratic is the only one of those 3 that changes direction.
Oh, so it's not always going to be like that.
There are others that we haven't talked about yet that change direction. But for our purposes right now, yeah, if you look at something and it suddenly changes direction, that's quadratic. Yeah. Oh, you're right. It's 2, 9. I'm sorry. But that doesn't really change anything we've talked about. But thank you for pointing it out. Okay? All right. Anybody have a question about that? Okay. The next one, -2, -11, -1, -5. Did I get this one right? Okay. What do you notice about this right away? It is a parabola. It's a quadratic function. And it's pretty clear that this is going to change direction. It's going up this way and then suddenly turns around and comes back down this way. Okay. Okay. And then the next one, what about that? First of all, did I graph those properly? Okay, good. Yeah, that's about as linear as it's going to get, right? I mean, if I take a ruler and line it up right there, yeah, that's a straight line. The next questions I asked you to do were 9, 10, and 11. And I asked you to use differences or ratios to figure those out. Okay. The first one, if you do the differences are not common differences, but the differences of the differences are. So that makes it what? Quadratic. Okay? This is how you can tell if you're working with a table. If you're working with a table of numbers and you take the differences and they have a common difference among them, 2, 2, 2, that's going to be a quadratic equation. Anybody have a question about that? Yeah.
Sorry, can you tell me how it's been lost then?
Yeah. So we're taking the difference here between negative 12 and negative 11, and that's a positive 1. Negative 11 and negative 8, that's a positive 3. Negative 8 and negative 3, that's a positive 5. So we know 3 different kinds of functions that we can look at here. One of them has a common difference. One of them has a common ratio. This doesn't fit into either of those 2 categories. But the third one we discovered was if you took the differences of the differences, the difference from 1 to 3 is 2. The difference from 3 to 5 is 2. The difference from 5 to 7 is 2. The differences of the differences, right? Take it a second column. If they're the same, if you have a common difference there, that's a quadratic function. The next one, number 10, right here, that's number 10. And it was pretty straightforward. If you go through it, you had common differences all the way through. From 0 to 1, you're subtracting 3 minus 5 is negative 2. Negative 2 minus 5 is negative 7. Negative 7 minus 5 is negative 12. What kind of function is that? What's that? Right, it's an arithmetic sequence and a linear function. Okay? The sequence refers to the numbers themselves, 3, negative 2, negative 7, negative 12, negative 17. Okay? And the word function refers to the rule that applies to these. Right? Whether you're talking about a rule that you say orally, like start with 3 and then start subtracting 5 for each one, that would describe a function. Okay? The function is the rule that makes this happen. The sequence is the actual series of numbers, one right after the other. And the sequence is called an arithmetic sequence. And the function is called a linear function. And it's called a linear function because when you draw it, it's going to be a line. Okay? And since we know that the common difference is negative 5, what do we know about this? What does this have to do with this line? Any ideas? Yeah, it's going to be the slope. Negative 5 is going to be the slope, so it's going to go down. What else do we know? Just looking at this. What's the y-intercept? 3, right? Because if x is 0, right, then y is 3 right here. So here's 0, here's 3. Can we write an equation for this? Yeah. We could write an explicit equation for this really fast. Y equals mx plus b. Right? Not so hard. Okay. Questions about that? Okay. There are other methods too, but this one, something you already learned. You don't have to learn something new. You can use what you already know. The next one, number 11. Okay. So we take a look at this. I started out thinking, well, okay, let's see what the common differences are. From 3 to 12, that's 9. From 12 to 48, that's 36. From 48 to 92, that's 144. Well, not only is there not a common difference here, but if I took the differences here, there's no common difference. This is not either of those two. It's not a quadratic. Right? It's not quadratic. Right? It's not linear. But there is a common factor right? A common ratio here. From 3 to 12, we multiply 3 by 4, we get 12. We take 12 to 48, you multiply it by 4. 12 times 4 is 48. 48 times 4 is 192. 768, well, that's 192 times 4. Okay. That makes this an exponential function. Do we know how to write an explicit equation for this? We do, right? What do I do?
Take the first value.
You mean this one here?
Oh no, wait. I did the 0 value.
You did this one?
Yeah.
Okay, so what did you do?
And then you multiply that by the common factor to the x minus 1 power.
3 times 4 to the x minus 1. Okay. So basically what you said was if we take f of x and we multiply, we take a1 and we multiply it by the common ratio raised to the x minus 1. Is that right? Well, let's think about that for a second. What if the answer, what if x is 1? Does that work here? Remember, anytime you write an equation, what you're saying is this equation is the rule that will give me this number if I tell you this number. If I tell you what this number is, my rule will tell you what this number is. So let's plug in 1 and see what we get. F of 1 is equal to 3 times 4 to the 1 minus 1. Okay, 1 minus 1 is 0, and 4 to the 0 power is 1. 3 times 1 is 3, right? So if x is 1, this equation says f of x will be 3. Let's go back over here. That's not the rule that goes with this. Yeah. The 3 would have to be 12. Okay? Okay. Right, this turned out to be 8. Okay, so 12 times r to the x minus, times 4 to the x minus 1. Will that work now? Hang on just a second. I'm asking if this will work. Plug something in. Pick a number. That's an easy one. 12 times 4 to the 1 minus 1. That's 12, and that is what we wanted. Let's try 2. 12 times 4 to the 2 minus 1.
48.
That's going to be 48, and that works. Okay? So this actually worked out. You were going to... Can we fix this without making this 12? I'm trying to fix this without turning this into a 12. Can I fix this so that this is f of x is equal to 3 times 4 raised to the something power and still have it right? Change the power to what? Just to x. Does that work now? Right. Plug in 2. Right. Plug in 2. 3 times 4 squared. What's 4 squared?
16.
Times 3? Hey, that worked. These two, this one right here and this one right here, they are equivalent equations. They're rules that say the same thing. They're two perfectly good equations for the same function. All right. Yeah.
Wait, so when you say like value.
Right. If we're talking about the first value, it's A1.
Okay.
If we're talking about the 0 value, then we're saying A0 times the ratio to the x.
So when the 0 value.
All right. So the one last thing I asked you to do was to take this sequence here and make an equation for it. So this is what we're looking at if you just look at the sequence. Okay? If you take the sequence of numbers, -3, -8, -1, -2, 0, 1, and you don't graph it. You don't have to graph it in order to find out what kind of function it is. you notice that when I took the differences, one of them was 6, one of them was 3, another one was 3, then another one was 6, and I started wondering what's going on here. It feels like it should be a common difference, but it's not turning out that way. And then I looked and I realized we skipped a number on the left side. Right?
Yeah.
If we fill in the gap there, -3, -2, -1, 0, 1, 2, 3, now we have a common difference. Okay. Common difference is 3. And looking at 0, 1, that would be the y-intercept. Well, if I know the y-intercept and I know the common difference, I know the equation. The pattern here is if I have a common difference, but I'm only going to have a common difference on this side if I have a common difference on this side, if it's linear. -3, -2, -1, that would have worked. Or if I went -3, -1, +1, 3, right? Then the common difference would have been 2, 2, 2. And over here, the common difference would have been 6, 6, 6. Right? The only way if it's a linear function, you'll get a common difference over here if you have a common difference over here. And the ratio of those common differences, if I had said 2, 2, 2 over here, and 6, 6, 6 over here, the slope would be the ratio of those common differences, 6 over 2. If I fill in the blanks and I have 1, 1, 1, 1, 1, 1, and over here I have 3, 3, 3, 3, 3, 3, the ratio is 3 over 1. Same ratio. It's a linear function. Okay? But yeah, you're right. Sometimes there are going to be numbers missing. Sometimes there'll only be one number missing instead of 2. If I give you any one of these 4 descriptions of a linear or an exponential function, first of all, you should be able to tell me whether it's linear or exponential. And then secondly, you should be able to give me the other 3 ways of expressing it. That is the essential standard. That's what you need to know how to do.